All right, cool. So oxidation numbers, these are basically kind of like charge. Let's call it that, kind of like charge. The only difference is this. In a covalent compound, the individual elements also have oxidation numbers. And even in a neutral element, they have oxidation numbers. So it's not just for ions, but it's for everything else too. So to say that a different way, imagine how we have charges for ions. If we wanted to have charges in other things, this is what they would be. So that's what the numbers are. So rule number one here, since we rules here. Oh, this is going to be a little bit messy today. So for individual ions, the charge is the oxidation number. In compounds, we use the following rules. There's basically five rules. So here they are. Some of these will be the same rules as what we already use for ions, some won't. And the reason I write these rules is that sometimes two things conflict, and so you got to pick the rule that comes first. Kind of. So number one, alkali metals are +1. So this you already knew. And here they're always going to be +1. 2. Kelly, can you shut my door, please? Alkaline earth metals are +2. Okay. 3 halogens are -1. And here's something we're going to add to this. So you put in parentheses, even in covalent compounds. Alright, so in ionic compounds we know they're -1. But if we're using oxidation numbers, even in covalent compounds, we're going to say they're -1. Even though they technically don't have a charge, they have an oxidation number. For oxygen is -2. And again, same thing. In both ionic and covalent compounds can have the oxidation number -2. And finally, last one, hydrogen is +1. So for everything else, we use these rules to figure out what the oxidation number is for other stuff. So let's, I guess I'll write here. Here's some examples here. Let's do lead chloride, PbCl2. Okay, so we want to break this down. We want to know what are the oxidation numbers for lead and for chloride. So, what are your thoughts? Well, do either of these fit into those 5 rules? That's the question, right? Either lead or chlorine. And the answer is yes. Chlorine is a halogen. So the chlorine is -1, and that's always -1. And then you remember we talked about this before, the charges have to add up to 0. So chlorine's -1, there's 2 of them. So that means they have the -2.
Excuse the interruption. Was Sarah Monzik? Please call 2503. Sarah Monzik, 2503.
So what's the lead going to be? +2. So that's it. So it works the same as balancing the charges with ionic compounds, but this also works with covalent compounds. What if we had a different compound? What if we have PbCl4? Okay, again, a form of lead chloride, different formula. So what are we going to do here? Yeah, the lead's going to be +4, because the chloride is always going to be -1 because it's a halogen. So the lead must be +4 if it's paired up with 4 chlorines. Let's do 1 or 2 more. Copper oxide. Okay, which one do we know here? Oxygen's -2. So what's the copper? 2, +2. And then, like I said, these rules apply with covalent compounds too. So we could have oxidation numbers for the elements in carbon dioxide. So what about these? Which one do we know? Yes, oxygen's -2. What's carbon going to be? +4. Right? So really it's just like dealing with charges, except for we do it in covalent compounds, which don't have ions. So they don't have charges, but they have oxidation numbers. That's pretty much it. Questions? All right, we are done. So we'll turn that off, please. Mohammed, it's your job today. You're late. So you want me to turn it on? Yeah.